All right. So this is our, I guess, fourth now meeting for this kind of working group. And it's been a bit, it's been like 6 months. We've been on a bit of a hiatus, but we're kind of back at it. And we've got probably a few speakers lined up. So we're hoping to keep a bi-monthly cadence probably through the summer. And we typically kick off with a bit of a community update or lightning talks. So I think we have one. I know Ryan's going to just give us some updates about what's going on at Foam. And then there's an opportunity after that, if anybody else just wants to introduce themselves or their project. We've got a good number of folks who've been out to a meeting before, but if you're new and you want to just say hello, talk about where you're coming from, your interest, that's awesome. So let me pass it over to Ryan. We'll do our updates, and then we'll have Jed Sundwall, our featured speaker, take it away after that.
Thank you, Taylor. Great to see the working group back in session, and looking forward to them continuing through the summer and today's. My name's Ryan. I'm co-founder of a project called Foam. You can find us on Twitter at foamspace or the website foam.space. We're working on what's called proof of location. So this is about how to get secure verified location claims on a blockchain. And our approach uses a terrestrial radio-based system. We call them zones. And each radio is a zone anchor. And you need at least 4 to set up a zone of coverage. And we've been really focused on the hardware side, testing through our beta program in different geographies. But our most recent updates are we've been putting a lot of our attention on the blockchain side of things and have been developing on the Optimism Layer 2 developer stack, and recently launched an MVP of this end-to-end system of proof of location where a user can have a mobile transmitter communicate with a zone, sign a cryptographic message, and ultimately mint an NFT that represents their what we call a presence claim or their proof of location, that then can be used in other applications that require secure location data. So you can check this out on our Twitter and blog. And we still have a kind of rolling invitation for beta testers, hoping to do so with Taylor in the near future at the University of Maryland. But my email I can put in the chat if anyone wants to reach out. And thanks for this opportunity to share the update.
Awesome. Thanks, Ryan. Anybody else interested in doing an intro or a quick update?
Hey, Taylor, this is Danny from Astral. Yeah, I'd like to just maybe introduce our project and kind of what we're focused on, if that's okay.
Yeah, please.
Yeah, so thanks for everybody for joining here. We're excited to be here. John, myself, and Ron over here at Astral will be here, but kind of focused on, trying to equally bring on-chain or physical locations on-chain. I think we have 3 hypotheses or 3 things we're focused on. First, kind of being spatial registries and the ability to kind of create those spaces and those boundaries. And then second, somewhat similar to what y'all are doing at Foam, but a little bit different with the verifiable claims and being able to bring those on chain. And then the third piece is really trying to establish those standards, working with communities such as this to ensure that location data can be processed by smart contracts and allow for that kind of infrastructure. We see ourselves more as a kind of a foundation, trying to also experiment with being built completely solely based on public goods funding. So we aim to have this spatial registries contract that would be deployable sometime in this quarter, and actively would love kind of a call to action for everybody here. If anything we're working on is of interest to you, we would really love some feedback and potentially even looking for some pilot users just to kind of give us that feedback as we continue to try to build. So really happy to be here. Please let us know and let me know if there's anything I can do to help you. You can find us at astral.global, and yeah, so happy to put some more information on how to find us in the chat.
Awesome. Thanks, Danny.
Yeah,
and then we'll just do a quick demo, actually. So we've got from our team here at UMD, Matthew has been working along with others on a bit of a dashboard. One of the things that we've been interested in exploring is just combining decentralized web metadata with kind of more traditional geospatial web metadata. And so we've got a bit of a dashboard prototype on how some of those components can play together. So Matthew, if you want to do a quick demo, we've got a few more minutes.
Yeah, sure. I'll take it away. Okay, I am now sharing my screen. So We've recently deployed a very alpha version of this dashboard here, which the main goal is to easily explore geospatial data that has links to Web3 enriched infrastructure. So that would be IPFS and Filecoin. So what we have here is some Landsat or tiles that are associated with Landsat 9 assets over the United States. And if I click on one, let's see, you can see that we are now fetching IPFS node data, and we get extra metadata regarding the Filecoin CID, the IPFS CID, and this also comes equipped with a Chrome extension that I have here configured to a local node that is running in the background. So if I share my screen here, you can see we have two assets that are currently being pinned. If I want to make this scene in particular more accessible within the ecosystem, I can just hit pin to local, and eventually you'll see that it is successfully pinned. And now we have a third scene here, which is now stored on my device, on my node. So if I take a look at the extension here, I can see all of my recursive pins are basically lined up with what I have here in the IPFS desktop app. And I have it configured to my local node here. And in addition to making data more accessible and viewing the metadata, we also have integrations with a Python client that we've written called IPFS Stack. And this allows us to seamlessly fetch data and integrate data from IPFS through their CIDs into your Python programs so that you can easily run them or easily grab and integrate this data into whatever Python workflows that you have written.
Awesome. Thank you, Matthew. And the idea here is that a lot of this should look basically like stuff that folks are already playing with. It's all based on existing things. So just ways to grab IPFS hosted data through some of the usual channels. Awesome. Any other quick community updates? Maybe have two more minutes.
Can I do one real quick, Taylor?
Yeah, please.
Okay, hey, I actually posted a little comment in the chat here, but I'm Carson from Textile and Tableland. Been around the IPFS and Filecoin space for a pretty long time, 2016 or something like that. And we're actually right now, my team is exploring evaluating some like S3 style APIs over decentralized storage networks. So this is like sort of end-to-end verifiable data puts and gets from S3 style APIs. So if any of you are actively storing geospatial data on S3 or via S3 like style APIs, I know MinIO or similar, I want to talk to you. So my email address is carson@textile.io. I posted it in the thing. Yeah, let me know if that's of utility for you. In particular, I'm particularly interested in like the concept of data provenance. So like changes to a particular data source over time and being able to verify those changes and in a sort of end-to-end way. So let me know.
Cool. Perfect. All right. So without any further ado, we can transition over to our featured speaker. So we are really fortunate. We've got Jed Sundwall here today coming from Radiant Earth. And so the kind of preamble I'll just share with everyone is that Jed's not planning to talk on anything really particularly decentralized, or DWeb rather. He's got multiple different projects, initiatives, and everything running through Radiant Earth. But they do cover a lot of the cutting edge of the geospatial web, cloud native geospatial, and different, I guess you'd call them, standards and best practices for sharing geospatial data and making it accessible. So I thought for this group, it'd be a really unique opportunity to have that introduction and that exposure. There's also a lot of maybe principles that do share, I guess, overlap with the decentralized web, the values, and I think of the decentralized web as kind of a spectrum of things you can do from technologies to social organization. And so there may be some overlap there, I think, and I think that can be a really cool point of conversation. So I'll let Jed take it away, and then we'll have plenty of time for discussion after that.
Awesome, thanks. I missed some of your intro because I was emailing Carson because I'm very interested in what he's doing. This is great. No, it's a great. That's a perfect introduction. I'm really happy to be here. Yeah, and to have this conversation. So yeah, I think the time that I have allotted, there's just we have a lot going on at Radiant, and it's very easy for me to get deep, and there are a lot of different sort of like patches of weeds that I can get lost in here. So I'm going to try to keep the slides kind of short because I want us to have a lot more of discussion about the overlap between our approaches. So first of all, so Radiant has been around since like 2016, 2017. It was initially started by the Gates Foundation and Amidyar as those the initial funders to improve access to satellite data and drone imagery, and to create a sort of a shared platform for imagery to be shared and analyzed, particularly by like international development projects in low and middle income countries. And we've had an interesting history since then. I took over the organization as executive director about 1.5 years ago. Before that, I'd been at AWS for about 8 years, where I built the open data program and did a lot of stuff with opening access to satellite data there on S3. So that's why I'm very interested in what Carson is doing, because basically built a program that hosts now over 100 petabytes of data in S3. But came to Radiant Earth because I became convinced that we need nonprofit organizations that can manage this kind of infrastructure for the world. And so we have a number of initiatives going on. But before I get into those, I do want to explain kind of our mission and the philosophy behind what we do. And so it's just right here on the slide is that our mission is to increase shared understanding of our world, or foster shared understanding of our world. And the way we see it is that we are an increasingly globalized species. We have a global economy. We interact. We're constantly flying all over the planet, meeting each other and interacting and engaging in commerce with each other, as well as fighting with each other and things like that. And as a result, we can perceive global challenges and things that we believe we need to cooperate on as a species. But we don't have a lot of great institutions that are equipped to do that. We have multinational corporations, we have nation states, we have a few international NGOs, things like the UN or like the World Bank, they're international institutions. But very, very few institutions are really equipped to share data at planetary scale. And that's something that we're trying to solve. And so anyway, yeah, it's a pretty big mission, but it's fun. And then the good news is that like the internet exists, and there's the web exists, and we actually have the capability of doing this, but we need to figure out ways to do that in a way that's ethical and where data is actually accessible to people who can use it the most. And so that's where Taylor, I think like we're very aligned philosophically. Like this is a problem that I think a lot of people perceive, and we're trying to figure out like what's the best way to go about it. So let me get into the initiative. So we do two main things at Radiant. One is we focus on what we call cloud native geospatial data. And so Taylor called them standards. We avoid the term standards because the Open Geospatial Consortium is the standards body for the geospatial sector. We don't want to step on their toes. We're friends with them. We like them. But we do perceive the need for more work on like bottoms up approaches to finding patterns and best practices for working with data on the internet. And when I say the internet, it's really the web. Like how do we make data flow more efficiently over the web? And I'm going to talk about this in a little bit, but like there are a lot of file format standards and conventions that people have been adopting that allow data to be used very performantly on the web. And so that's the kind of stuff that we encourage, and we want to drive adoption of that because we think it increases shared understanding of the world. The other thing we do is we run a thing called Source Cooperative, which is a data publishing utility that allows people to share data over HTTP. and that's it. It's I'm going to give a tour of Source in a second here. So those are the two things we work on. So let me let me show you Source. So first of all, this is what Source looks like. If you go to beta.source.coop, this is what you'll see right now. If you just go to source.coop, you'll see there's just like kind of a landing page just announcing the product, and there's a link there to a blog post, a pretty long blog post describing what Source is. So if that's of interest, go check it out. But let me just give you a quick tour. I'm gonna this is a little risky here, but I'm gonna switch the screen that I'm sharing so you can see Source. So once again, this is Source. We take a lot of cues from GitHub in terms of like the overall experience. We have the concept of repositories where you put content. And what a repository is it's you get a URL, you get a title, you get a description, you can put on tags, you can see who created the repository. This is all very similar to GitHub. And then continuing the theme of similarity with GitHub, there's a README that gets rendered right away. And all of this is just driven by content that's put into S3 or Azure at this point. So this is just an abstraction on top of S3 or Azure, where you put a bunch of objects into a bucket that we manage and maintain when we make it visible over the web. And so you can click through the bucket and you can go to files, you can download them if you want. One thing that we've started working on is also a thing that we call source viewers, where certain file types that are truly cloud optimized or web optimized, we can preview them in the browser. So this is a good example of one where there's a PM tiles file. So a PM tiles file, this is an example of what we would call a cloud optimized geospatial format. It is a mapping tiles format that allows you to stream very large map tiles data products. And so this is a combination of two data sets that Google and Microsoft have released of building footprints. It's about a little over 2.5 billion building footprints. And they're made available in this PM tiles file that you can see here. It's about 200 gigabytes. Now, I don't have 200 gigabytes of storage on my machine, so I can't download this. But what we can do is we can stream it through the browser because it's cloud optimized. And so I love this demo because it's like almost too fast. People don't believe it's real. But like, so I can zoom in here, pretty sure this is Sao Paulo or like near Sao Paulo. And it will just render the building footprints. You can go anywhere in the world. So yeah, so anyway, so this is what PM tiles looks like. And one thing that we were like sort of aspiring to build here, to be somewhat audacious, is like a finder for the entire internet, like kind of like your operating system, your file browser. We want to produce that kind of thing where it's just like, this is a place where you can put files and make content available for anybody to see, and make it visible on the web anywhere in the world. And part of the theory behind that is that like the web is a pretty well distributed technology. Like browsers exist everywhere. To the extent that we can make data available in ways that are streamable or cloud native, and again, I'll talk about this more in a second. We can make data visible. And I don't even know if this is a word, but I use it all the time, like scrutable to people. Like we want people to be able to like see the data as an entry point for them to understand like what's accessible to them and what's available to them. What we aren't with Source Cooperative is any kind of like analytics platform. Like you'll notice here, like you can see the data, you can view it, but like there's no way to like analyze this or do any sort of transformations on it. What we want people to do is to be able to grab these URLs and put them into notebooks or put them into other tools and build on top of them elsewhere. One of the sort of the challenges that I perceived, again, working in industry, is that there are a lot of attempts at data publishing or sort of like data marketplaces always being released, but they're almost always linked to a particular technology, like a particular software vendor or infrastructure provider. And what we're trying to create is I call it like data Switzerland, where the data is made available, but in the most neutral way possible, where we don't have opinions about how people are going to use it. so that we're not necessarily steering anybody in any particular direction. And we think ultimately that will allow or encourage the development of a much more diverse range of tools for people to work with. All right, so let me do a quick time check. Okay, yeah, okay. So I've mentioned this term cloud native a few times. It's actually a sort of difficult term to describe, but roughly they're file formats that are read oriented, meaning we're optimizing for the files being read rather than being written and written over and edited a lot. So we're less concerned about with the data products that we host and source with like version controlling stuff like that. We're more we're designed for these formats that are basically, it's like once you've produced a data product and it's fully baked and done, you publish it. Now a lot of these formats are they benefit from what are called partial reads or range requests that you're able to make over HTTP. So for example, the PM tiles file that I was just showing you, it's a 200 gigabyte file. You know, no one ever needs to see 200 gigabytes of information all at one time. You want to be able to just stream that data. And so, and the way that that's done is through the glories of a space filling curve called the Hilbert curve. You should go to, just look up PM tiles or proto maps and read all about it. I love this stuff. But there are ways to create, you know, these files that allow you to do range requests and allow you to stream geospatial data in these ways. But that's not what it's necessarily all about. For example, you know, in the presentation earlier about you know, showing off the interface to Landsat data, that took advantage of a thing called Stack, which is Stack is a metadata specification, stands for Spatiotemporal Asset Catalog, that we also helped foster and create and build a community around that. That it just uses little JSON files that are, again, read oriented, intended to be read over the web, that allow you to traverse and navigate very large collections of geospatial data. If you want to learn more about this, the best place to go is guide.cloudnativegeo.org. It's a tremendous guide, very robust overview of the whole ecosystem of file formats and standards that was produced by our friends at Development Seed with support from NASA. So yeah, I'm not going to belabor this, but like the point of this is that like we want people to be able to just put data on the web and then get out of people's way. And these formats allow you to do that. They allow you to draft off of things like S3 or Azure Blob Storage or Google Cloud Storage or any S3 compatible object storage server. And basically what we're saying is like, if you're thoughtful about how you've prepared the data and the metadata, you can put the data up on these services that are, you know, very widely adopted and well supported, and then get out of the way and people can build things on top of them. It dramatically lowers the cost of both publishing data and then building on top of data. And so the way that we think about this is that, you know, we're using the cloud to do this. We're using very, very centralized services, you know, so they're controlled by a few mega corporations. But they're good, you know, so they're performant, they're low cost, they're widely adopted, widely supported, and reliable. And so for the foreseeable future, we think that these are technologies that they're not really going anywhere, and they're going to have a broad support. And one of the ways we think about this is in terms of what's called pace layering. This is from Stuart Brand, but this idea of like how culture and life as we experience it is built on top of these layers of things that move at different paces. And so if we think of like the internet being built on, you know, just internet protocol, and then HTTP being on top of that, standards can be formed on top of HTTP. And as those get adopted, they kind of like set in place. And then as people deploy more and more sensors, typically the data that is produced by those sensors will then be shared using those standards that are HTTP aware. And then on top of all of that, we can build all sorts of crazy interfaces and tools and things like that. That's the world that we want. So thinking of these layers, the source cooperative is this thing that's basically trying to make it easier for people to fully benefit from performant data storage over HTTP, or delivery of data over HTTP. And then the Cloud Native Geospatial Foundation is where we focus on like what are the metadata specs and file formats we need to make that like actually work well. So then the question is like, what about IPFS in here? So the nice thing about IPFS, to my knowledge, and again, I'm not an expert, is that like it plays nicely with HTTP. You know, like it's deliberately different from HTTP, but you can have HTTP gateways, and voila, you know, we just saw this in the previous demo of IPFS stack that allows you to, you know, host use stack to point to I guess CIDs, you know, on IPFS. And so this is what it looks like. Great, you know, shout out to the Easier Data Initiative. I love that this research has already been done. But you can take the metadata standards that we've created to share data over the web, and we have the ability to point to data that's on IPFS, you know, no problem. And I think the demo that John Solly, I mean, the work, I don't want to like give credit to the wrong people, but I've been paying attention. I know that John Solly's been doing a lot of this work, and so anyway, it's great to see that it's possible. So, but our perspective on this is more about like how than what necessarily as well. So like obviously I've said that like we're using object storage and relying a lot on cloud-based object storage, but because like what we're trying to do is focus on something that we can distribute globally very quickly, and they can drive adoption really quickly. We measure our success in terms of like how much data we can make available, how much that data is actually being used, like tools that are being built to interact with it, how many people we can get involved in the community and things like that. We're still figuring out how to count these things, but like this is the kind of stuff that we care about, is just like actual bytes moving, adoption of formats and things like that. One thing I want to point out, so this is great. I actually just talked to UV yesterday. So he's one of the founders of 2i2c, which if you're not familiar with 2i2c, it's a Jupyter Hub hosting service. It's a nonprofit that makes Jupyter Hubs like easier to access to people. And so I'm just going to quote him directly, but he talks about the cloud being run as, you know, all the cloud is run by ruthlessly competitive hyper-capitalist large-scale organizations. This is true. I can corroborate this. Now, but the thing is, the cloud, like I said before, it's performant, it's well supported. It's the other good thing is that like the cloud sector is just competitive enough to be putting downward pressure on pricing, and encouraging continued like innovation in terms of functionality and just performance. And so it was just like a few weeks ago that I think, you know, Google made this announcement to, I don't remember the details of it, but it had something to do with their data transfer costs, to make sure that people don't feel locked in by hosting a lot of data on the Google Cloud. They have some sort of affordance for you to get your data out of the cloud without being charged for it, right? And so, but they're doing that because of competitive pressure. So the market, you know, you say what you want about the market, about markets generally or capitalism generally, but the competition works pretty well to make these services work. Now, and the other nice thing about the cloud is that it is becoming commoditized. So there are layers of the cloud, like object storage, that are basically total commodities. So the approach that we take is fully aligned with what UV describes in this blog post, which is like write open source applications to make sure that like anyone can port whatever they're doing to other clouds or on their own hardware. And that's, you know, that's the approach that we're taking. But just for practical reasons, we take advantage of the cloud right now. And then it's also worth pointing out that our work is very heavily subsidized by cloud providers. So like Source Cooperative is largely built on S3, and the storage there is subsidized and sponsored by the AWS Open Data Program. So this is where I think this is my last slide. Oh, no, is it? Oh yeah, okay. So I have this slide twice. So yeah, as we enter the sort of the discussion phase, I guess I just want to like open up the conversation. There are a lot of ways to distribute power and to mitigate concentrations of power. So like IPFS, Web3 stuff, these are technical architectures that are really appealing because it's the kind of thing where it's like, well, you just build a system that like is distributed. Like there's kind of like no other way for it to work. It requires a shared, you know, a coordinated distribution of power and of nodes. So it's really impossible for people to concentrate too much power or authority within these technical architectures. What I would argue, though, there's also other stuff we have to be looking at. So there's like legal ownership structures. We, for example, are a nonprofit, so we're subject to regulatory standards and practices, audits, and things like that. We have to publish our tax filings and our financials in ways that other organizations aren't. Even publicly traded corporations, they're also subject to regulatory standards that require certain kinds of governance. So I also like to point out that like publicly traded companies are cooperatives. They're cooperatives just in that the members of the cooperative own all the capital, and they only care about returns on that capital. So they behave in a certain way, but they're also cooperatives. One thing that I'm very interested in here is this third point is cooperative utility governance. So this idea I got from like, learning about how in rural areas of the United States, and I know this occurs in lots of other parts of the world, but I know mostly in the United States, I know about this, where few businesses will set up shop to run like a power plant in remote rural parts of the country. And so farmers or people who live in rural areas, they often band together to build their own utilities. They'll build their own power plant and share it. I'm really interested in figuring out, I mean, in fact, this is the name, it's in the name Source Cooperative. Like, we're building Source Cooperative with this in mind, is that it should be a cooperative utility. It should be a service that people who need to publish data I wouldn't say they own it, because we're a nonprofit. No one can own a nonprofit, but they can govern it and have some sort of say in our roadmap and in how we're designed and things like that. I think I'm just sort of surprised that like the internet hasn't fostered more cooperative entities like this. I do think the spirit behind Web3 and IPFS is clearly like a cooperative spirit, but cooperative governance of organizations and of software, I think, is something that we need to keep working on this. And then my final point on this, though, is that like, the other way to distribute power is just like give more people more power. Like one of our sort of like mottos at Radiant Earth, and I came up with this when I was working at AWS. And so my friends that are still at AWS tell me that I shouldn't have stolen it, but I've taken it with me, is, our job is to make more data more available to more people. So like, how do we get more data out there? But how do we improve access to it? Like, what's the best way to like actually get it in people's hands and like practically allow them to use it? And then how do we increase the size and diversity of the community? We want more people to be able to work on this stuff, and we just have to be very practical about like how we get it into people's hands. And that's like, it boils down to stuff like just making better tutorials, giving people scholarships, giving people opportunities to come to events and learn from one another, just creating educational resources. It's really kind of like quotidian sounding stuff. It might sound kind of boring, but like that's really important work that needs to be done. And so that's the kind of, another element of our work that we think about quite a bit. So I'll leave it at that. So our website is radiant.earth. You can email us at hello@radiant.earth. The whole team gets that email address. There are just 5 of us. You can also email me directly if you want it, jed@radiant.earth. So I'll leave it at that, and we can have a discussion.
Awesome. Thank you so much. Got some virtual applause there. So I guess there's lots of ways we could kick it off. If folks want to unmute, we're not that large of a crowd. I don't think it'd be too chaotic. If anyone does have a question, you want to just unmute and kind of go for it, I can help moderate. We've got the chat box. I've also got plenty of kind of questions or exploration areas, but I want to leave it to other folks first, and then I can circle back. Anybody want to kick it off?
Hey, yeah, Jed, thank you so much for coming and speaking to this community, your work and the impact of it. It's so clear and it's so obvious, and it's really cool to kind of see you, now having done so much great stuff at AWS and now kind of in maybe more of a give back type of role in organization. I'd be curious as to your thoughts about, as we are all, very, very big believers in decentralized web and decentralized storage, where you see the pros and the cons of that, and then where maybe you think maybe more of a centralized system and centralized structures are still going to probably be more of the norm.
Yeah, so I mean, I think one place where I'm optimistic about the decentralized web, and I mean, and I hope this doesn't like come off as being offensive, but it's like for smaller data, right? Like most data that people have to share isn't like huge, right? a lot of our, like, sort of the sweet spot when I was at AWS that I found for AWS was with just massive data, right? Like those are the cases where the cloud really shines because the data is so big, no one can really hold it all locally, you know, and so making that accessible in a cloud environment just makes a lot, like for example, like the Lancet archive or like massive corpuses of genomic data or something like that. You really need the cloud for that kind of thing where the like the total sort of unit of consumption is monstrous, right? The other place where the cloud really shines there is also if you want to do large scale analysis. So if you want to turn on, you know, thousands and thousands of cores to analyze the data in parallel, you know, you really need the cloud for that. But those are like pretty exceptional use cases. Like there's a ton of like, you know, gigabyte scale data that needs to be shared more effectively that where you don't need the cloud for that. And I think that the decentralized web like really shines, like it makes a ton of sense. You know, the drawback there though being that like, yeah, if you were sharing data that always required sort of like large scale analysis or something like that, like then my sense is the decentralized web isn't great for that. But again, like that's just the exception. Like I think most use cases are pretty small. As I was doing research for this as well, you know, I came across, I'm sorry, I'm like blanking on, I was talking to a guy yesterday. I want to make sure I get his name right, but he works for Protocol Labs. Awesome guy. Yeah, David Gasquez, the guy, David Gasquez. He lives in Malaga. But just, you know, exploring like sharing Parquet files on the decentralized web and using DuckDB to analyze those things. Like, I think the other great trend for decentralization is just that like local compute keeps getting awesomer and things like DuckDB are so powerful that like the case to be made that you need some sort of cloud infrastructure to do even like what I think used to be would used to be considered like pretty large scale analysis. That's eroding. Like I think a lot more power is being pushed to the edge as local compute and browsers become more powerful. And I should also mention like WASM at this point, like, you know, WebAssembly as being another factor in this that's making the decentralized web like more viable for this kind of stuff. So
Yeah. We had a question from Kat, and kind of, I'm not trying to steal your thunder, but I was thinking the same thing as you were saying this, Jed, about like, what about this like hybrid model, right? Where maybe some of the data, of course, might be centralized, but then it enters into maybe more of a decentralized environment. We see that I'm a big decentralized finance guy, and they see this with they call it DeFi mullets, right? Where the front end might be very Web 2 based, centralized, but then on the back end, it's using the infrastructure and the benefits and the composability of decentralized financial primitives. Well, do you think that there is something there, you know, specifically from a data sovereignty perspective?
yeah, I mean, I think so. Like, let me think through this really quickly. I mean, like this is actually, now that I'm, you know, I'm not at AWS anymore. I know that my friend and colleague Chris Stoner is on here, so she works at AWS. So anyway, hi Chris. Now I can say stuff out loud that I didn't say at AWS. Is that like it's really awesome when you host data in the cloud, but then you can do all the compute locally. Like, and it's again stuff like DuckDB makes that increasingly possible. Where the story that I used to tell all the time was like, oh, you host data in the cloud and then you have to work with it in the cloud, right? That's increasingly less true. So these hybrid models really do, they're more and more viable and feasible. So where you can have data hosted somewhere centrally, but like all the compute or action or sort of like derived products and things like that are happening at the edge or in external nodes. Yeah. So yeah, I think, I mean, it's been fascinating to see how, at least from my perspective, how the increases in power of browsers and local compute are changing the narrative on data. I mean, I don't know how many of you on this call have been like tracking the rise of DuckDB over the past year or so, but like it's pretty amazing.
There's also a project, someone had reached out to me and they were working on something, I think it was called Honeycomb, but they're looking to basically do more GIS through, I guess, WASM browser-based stuff as that becomes more efficient and just do it on the user's end. So that seems like pretty neat thing as well for adding that analytical layer.
Yeah, I think, I mean, and yeah, I've talked to some people in Jupyter community as well, they're pursuing this as well. It's like, okay, like what if we just run Jupyter entirely locally? Like you don't need a Jupyter hub at all. Like that's great. Actually, I want to double check though, on Kat's question in terms of like the data sovereignty perspective. Do you mind explaining a little bit more about the what are you asking there? Like, what's the question about data sovereignty?
Oh, hey, so I'm primarily a representative of the blockchain community because that's where I spend a lot of my time. I'm pretty OG there, but I've increasingly started diversifying in more hybrid models, which is also why I'm here. I went from decentralized science to seeing data usability, but I also do a lot of like public and social goods. And so I was talking about sovereignty more to the aspect of like a government running indigenous land contracts, which may be imprinted onto a blockchain, or banks rugging or nationalizing overnight. But if you were to, as an NGO, successfully deploy nodal structures and sort of like decentralized models also, as you said, petabytes of data cannot all sit onto decentralized infrastructure. They never really have the money for it. Then at least if 5 servers go down, one would survive for the duration of, let's say, a hot war for a couple of weeks before it went down to and sort of like leave an imprint on the web, because the internet is written in ink. So
Right. Okay, I see what you're saying. Yeah, I mean, actually, like that's another. This goes back to the post that I mentioned in my slides of the sort of the freedoms of open source in the cloud. Is that the good news is that like object storage has become, like I said before, like totally commoditized. And I've talked to groups that are working with indigenous populations that they don't want it. They absolutely aren't going to put their data in someone else's infrastructure that they can't manage. But like it's increasingly cheaper for somebody to like host an S3 compatible object storage service, like wherever they are, right? And so, yeah, I think I see what you're saying in terms of like they can run that kind of infrastructure and they can federate it or, have it be replicated, using some sort of decentralized approach that would give them, just sort of like greater durability of the data. Yeah, I think that's an interesting approach.
Yeah, it was also sort of like, it's more of a first world problem. I think we just don't think about it enough because it doesn't necessarily affect us as much. But there's a lot of like hot wars. For example, the war that happened in Burma, the Rohingyas at the border evacuated into Bangladesh, and it wasn't until they flew drones or checked geospatial data that they were able to do responsible journalism. I'd say the same thing for the Ukraine-Russia war, and very much the same thing for the Palestine debacle. And so this is only going to get increasingly common, and therefore the conscience of the people who custody such data is extremely circumspect, and it's very easy for a government to pay off an AWS or pull their licenses or threaten them or what have you. And it's just that domain that I'm thinking of, because I feel like that will be something I would worry about in like my grandkids' generation, but today it's already a problem in my own generation. So it's earlier than we think.
Thank you for that. Yeah, no, you're right.
Any other questions? So I've got one concerning kind of I guess you're talking about, I mean, it's source cooperative, and you're talking about like folks should be able to host their data. I was reading you could like just tag an AWS like an S3 endpoint, right? So you can host it somewhere else, but still have it basically feed through source cooperative.
Yeah.
Oh, sorry. Just like real quick on that. Like, could you envision it being possible for like multiple entities or organizations to basically own a data set being hosted there?
Yeah. So I'll explain sort of the model right now is that like you on source, I mean, this is where we're sort of limited by user interface design and stuff like that. It's like you can have an organizational profile, right? And so then the data set would be owned by that organization, right? So for multiple organizations to share a data set, it would have to be a consortium or something that owns that organizational profile. The other thing though is that like the way our permission structure works right now is that multiple people can be given ownership of a repository. Just like you can add multiple users to like an S3 bucket or something like that. And so you can have lots of people writing to it or contributing to something. You could do that.
Yeah. It was kind of building on Carson's comment about DAOs, the decentralized autonomous organization. So like, it's like another layer where you can have some kind of decentralized components, I suppose, but all going through kind of a curated system.
Yeah. It's funny. Like I'm rusty on DAOs. I remember being excited about DAOs when I first started hearing about them because of like as Carson says, like that's kind of like how cooperatives on the internet should work, maybe. But I'm too rusty to have a qualified opinion on this. But yeah, what I do want to just clarify something that you said, that like Source is built also to just be a registry, right? So like if you have your own infrastructure, you don't want to use the buckets that we're managing. We haven't done this yet, but in theory, like you can just register an external source within Source. And there's no reason also why that couldn't be content that's stored on IPFS.
Perfect. And I think that'd be neat, be kind of cool experiment to play with a little bit. Try and throw an example up there. And we've got some of the Landsat data. Well, it's on Filecoin. We're hosting part of it on IPFS, but having even like a blend, like if you could have multiple, I assume you probably can have multiple endpoints, right? You could have multiple sources registered for one data set.
You can, yeah. We're architected for that. We haven't done it yet though. So it's like we have a concept of mirrors, right? And so you can have multiple, like you could have a repository that had the data in Azure and multiple reasons of AWS, and also, I guess it would be Filecoin. I mean, yeah, I don't know. I'd have to figure out like what we would call that endpoint, because the conceit we have is of regions, which I don't think maps well to the decentralized web, right? So
everywhere, anywhere.
Yeah, everywhere.
Any other questions, comments? I can keep going. So I'm really interested in the idea of, I've also read like, data doesn't necessarily have to be open. It should be accessible, right? And part of the model is that you charge like a modest fee to cover costs, and data providers can also, there's no reason like they shouldn't be able to make money on their data. So you guys are kind of thinking about that. Like it's not there yet, but that's part of the plan to support everything in the long term. And so I'm just curious if on that you envision there being like an equal access plan, like, because I suppose I was reading there was the part where like they could control who can access it, and then they can have you can pay for it. So it's like, if you're charging, is there also then like an access level as well, right? Because that's kind of blends access with openness.
Yeah. So my thinking on this is that you have to get the sort of the framing right of like what is the product that you're delivering. So I wrote a blog post about this called "We Don't Talk About Open Data," and I'll share this in the chat, but like in case it's of interest to people. But like we think in terms of data products, right? So my mentality is like you should have data products. Well, so you have a data product, and then the openness of that product, that's an attribute of the product, right? So it's not like, what I'm trying to get away from is this idea that like open data is a category of data. It's like, no, like you have data products. We use this terminology so that people think in terms of like, what is this for? Who is the audience for it? What is the cost to maintain this product and deliver it and things like that? So if you have that framing, then you can decide, okay, how open is this? Is it fully open, or is it restricted access only to people I trust, who I can put on a list of people that I trust? Or is it restricted to people who pay me for access to it? And so I think the way we've built Source, most likely the way that we would move forward on this is that like, if you want to have a data product that's open, that's a subset of something bigger, just provide that as an open data product. Like have a separate data product that's the open one. And then you can say like, hey, like this data product will give you access to last month's data. If you want the fresh data, like as soon as it's produced, you have to pay for subscription or something like that. And I'm I think this is important, and like this is kind of like I'm a heretic here because I've worked in open data for so much of my career, like just being like, yeah, just open up the data, like what's the big deal? I now know like it's very expensive to produce good data, and it's hard to keep these things, you know, maintained and available. And so I think that by providing a like better market mechanisms for people to charge for access to data should ultimately actually lead to greater availability of more data. You know, you might have to pay for some of it, but I think there are data products that just don't even exist or aren't available to people at all right now because it's either like lock it down, build a proprietary SaaS company around it, or open it up. And that's just not, you know, we need middle paths.
Definitely. Any other questions, comments, follow-ups?
Jed, do you have an opinion on mesh networks? Do you think, I don't know if they're even legal in certain jurisdictions. I don't know if that's a thing, but Smart Mesh was this initiative abroad where they sort of talked about peer-to-peer internet communication, where you sort of not just own your data and you can emit to earn from it, but also sort of you don't need the internet. It's Internet of Things, and it pings from everyone's individual localized storage.
Yeah.
Do you have an opinion on this?
I don't. I mean, I've heard about mesh networks for. I mean, I remember reading about it in mesh networks when I was in grad school, like
Exactly.
years ago. Like,
Yeah.
not that long ago. I mean, my hunch is that like that's probably where things are headed. Is a meshier web. You know, this is yeah. If you allow me to like be an armchair like futurist, you know, like everything is being instrumented. You know, it's just like it's sort of like as we're still. You know, I don't know whether or not like Moore's law is holding or not, but like, it's just increasingly cheaper to add instrumentation to just about everything, and mobile networks are becoming more and more powerful. But there's no reason why like if we're putting chips in everything and sensors everywhere, why wouldn't we start having them all be interconnected? I can definitely see things going that route. But it'll be then. But then, then the inequality of that is going to become pretty interesting because you know, those networks will only work well where there's denser populations of people that have devices and access to power and things like that. So
Access to premium hardware, possibly.
right, exactly. Yeah. So fun to think about. But so no, I don't have opinions about it. I don't have any informed opinions, but I do like thinking about these things. So thanks for sharing that.
I think in particular, you've got things like those open data sets hosted by the US government, things like Landsat 9. I think it'd be really interesting to see if having that kind of additional IPFS endpoint or mirror or whatever it is can potentially help minimize some of the bandwidth costs, I guess. I mean, if you're storing it, you're already storing it somewhere, it's up there. But if there are costs associated with pulling it down and using it, if you can basically have that layer where, you know, if lots of users are using it and they're at least some of them are pinning it, you know, it can be grabbed from there. But then it's all coming from the same kind of trusted place. There's one more comment there.
Yeah. No, I mean, I think we're onto something there. I mean, this is sort of what content delivery networks do now, but there's still kind of also sort of kludgy. But it's something that's very interesting to me about like content addressable storage and things like SIDs. Do you call them SIDs or CIDs? I don't even know. Like, that like everyone knows that they're working on like the actual copy of the data, and the content itself is really, you know, the network is as efficiently as possible making sure that the content itself is available to the people who actually need it. And this is really important when we talk about global data sets, because I think that we often make a mistake where like, wouldn't it be cool if we had a big global data set that told us like everything about, you know, some characteristic of the world? It's expensive to maintain all of that. And again, and that tends towards like a sort of a centralization, like a centralized architecture to do something like that. When in actuality, the applications of that data are all happening locally, right? Like you actually need the data to move to like local places where people are able to make decisions based on it. And so, yeah, it's a constant push, like, I guess, like sort of tug of war there. But yeah, we're probably headed towards something meshier over time.
I know we're running short on time. There's a few minutes left, but this is a quick comment from, I think it was alluded to one of your blog posts. You wanted to have features for I don't know if it was like starring, but basically like analytics on usage. And I thought that was really neat and kind of like there's a parallel to, it's like a consensus layer, right? Like, is this trusted? Do a lot of people use this? It seems like a really neat idea.
Yeah, that's right. I mean, we need what I call the social proof, right? Like people are like, oh, you know, how is this data valuable? Like, how do you assure the quality of the data? I'm like, I can't really assure ex ante if data is valuable or not. Let's actually just all look at how it's actually used, and then we can decide if it's useful or not. So
yeah, definitely. Well, anyone else have any last comments or questions? Awesome. I think we'll move to wrap up then. Thanks so much, Jed, for coming out and talking. And I'll just shout out to, we have Bryn and Sankara from FFDW here who they've been supporting the work and the working group here at UMD. So thanks to them for also coming out.
Yeah, I just wanted to say, Jed, that was a fantastic presentation. I really enjoyed. You hit your target audience really well, and I'm going to follow up with you afterwards. So,
all right,
great.
thank you.
All right. Thanks everyone for coming out, and we'll send out some info about the next meeting in about a month or two. Take care.
Thank you. It was great.
Thank you, everybody.
Take care.
Thanks, everyone. Take care.